Okay, let's take a look at factoring by decomposition. It'd be nice if I could spell what. Is the perimeter of a square with an area of, so they gave you an equation for an area here, okay? So we want to actually visualize getting a square. So what's special about a square? We know that, yes, all four sides are going to be the same. So in other words, our answer, when we go to factor it, okay, because we're going to factor it into something, these two things should essentially be the same in order for it to be a square. Or in fact, our answer should be able to be simplified into one bracket squared. We just don't know what the expression is going to be yet. How do we, and sorry, once we've done that factoring, then we can go into the perimeter, okay? So what we're doing is we're factoring to find the actual sides of the square. Why are we factoring to find the sides of the square? Well, what is area of a square? Area of a square is equal to a side times a side. And since both sides are the exact same, it's technically s squared. So that's where we're getting that little, where we know it's just going to be one expression squared here. So in order to take an expression and bring it down to a simplified version, we're going to go through factoring. So we'll put it over here. We have 4x squared plus 12x plus 9. So using decomposition, we're going to find two values that are going to add up to whatever the a and the c value multiply to. So we're going to take a and multiply it by c. And in this case, that's the numbers 4 times 9, okay? In fact, I should probably move that over, but that's okay. We'll do it down here. So 4 times 9 is, do it in red. 4 times 9 is going to be 36. Wonderful. So we need two numbers that are going to... Okay, the two numbers are going to add to that value of 36. Nope, I lied. Multiplied to 36. And they're going to add to the middle term, which is our b term here, which is 12. Wonderful. Okay, well, what's nice about this is I can keep the idea of a square in mind, and because it's a square, I'm looking for values that are actually the same. Well, there's two numbers that multiplied that are the same. So 6 times 6 is 36, and 6 plus 6 are 12. Wonderful. So let's go back to our standard form of the quadratic, and we're going to split this middle term. So now it's going to read 4x squared, that still stays the same, and the plus 9, that stays the same. But this 12x is now going to be split into 6x plus 6x. In other words, if I put them together, if I added them together, they would create 12. But instead, I'm making this, think of it like expanding. I've expanded that middle term. Okay? Let's shrink this a little. There you go. Now let's continue. Okay, so now that we've done that, what we kind of want to do is we want to think of these as almost like they're two different expressions. So the first two terms are an expression, and the second two terms we're going to call an expression, okay? And what we're going to do is we're going to focus on common factoring the two of them. So I'm going to put like fake brackets. They're going to be dotted around them, and they're going to be a bit important for us. We're going to try to common factor both of them. So in order to common factor them, we look at the very first term. I can definitely pull an x out of it. I know it's hard to see. Ooh. I'm going to rewrite it here. Yes, that's right. So 6x. We can pull out an x. And what other term can we pull out? 2. That's right. I'll write that in red. So we can take out 2x from both those terms. So the common factor becomes 2x on the front of it. And what is left over? Well, when we divide them, we get 2x plus 3. Excellent. Second set of brackets, what can we take out of 6x plus 9? So think of it like I move that there and move that there. We can take the value of 3. Excellent. So when we do that, the common factor is the number 3. And we're left with
2x plus 3.
Amazing. So visually a little hard what I've done. I'm going to come back up on this side here. Let's rewrite it. So our expression, all we've done, we haven't changed any values. We've just written it a little differently. The expression that was originally 4x plus 12x plus 9, 4x squared plus 12x plus 9, is now written like this. We have it as 2x bracket 2x plus 3 and 3 2x plus 3. Now, what's actually happening here is you're common factoring again. You're actually common factoring out. Oh my gosh, that's kind of hard to see, isn't it? Why did it get so dark? Let's not use that. That's not much better. That's okay. We're common factoring out this bracket. If you notice, this bracket is the exact same as that bracket. Think of it as if that bracket was actually just the letter A. Oops. There we go. If that was just the letter A, think of it like we're commoning factoring out A. Visually a little hard. The easiest way to really think of this is I'm going to take the two terms that are outside the brackets and I'm going to put them into their own bracket over here on the right. Okay, so 2x, and that's because there's no negative, it's positive 3. And whatever the first two terms are, the ones we had in green, we're just going to write them once in their own set. Yeah.
And then it becomes 2x.
Exactly. So technically from here to here, this is another set of common factoring, but we just kind of think of it as take these two, put them into a bracket, take these two, put them into one bracket. Since these two brackets are the exact same, like you said, we can represent this as 2x plus 3 squared. Amazing. That makes a lot of sense. That's exactly what we predicted. So one of these sides has the length of 2x plus 3. Now, they didn't give us any units or anything, so kind of difficult to figure out. But now what we need to do is find the perimeter. Well, we talked about area of a square. Remember we said area of a square is a side times a side. Do you have an idea of what perimeter of a square might be?
Side plus a side times 2.
Side plus a side times 2. Yeah, that's one way you can do it. I'm going to shrink this a little more. So let's say perimeter of a square. What's a perimeter of any shape?
11 times 1 times 2.
No, that's not any shape. Let's say I had a shape that was like this. That's a terrible shape I've made. There we go. What would I do to find a perimeter of something like that? Yeah, we just figure them out. We just start adding sides to each other. Okay, so let's talk about a square. We'll call a square side S. There's 4 sides to a square, so it's S plus S plus S plus S. Okay, you said we can go side plus side times 2. That makes a lot of sense because I can simplify S plus S is 2S, right? And then it's plus another S plus another S. That's how you describe it. But I can simplify this even more. 2S plus S and plus another S. Do you know what we can simplify that into? Yeah. 4S. Wonderful. Do we know what S is in this case right now? S is representing the length of a side. Perfect. It's 2x plus 3. Amazing. So let's take our formula for perimeter of a square. So perimeter of a square is equal to 4 times, we'll call it S. And in our case, S is equal to, we'll write it in red here, what we solved before, so 2x plus 3. Well, we can use distribution property. We distribute the 4 to all of the terms, so we get 8x plus
12.
Perfect. Great. No units or anything, but we now know the perimeter of this square is 8x plus 12, and we know that the side length is 2x plus 3, and we originally knew the area. They told us that a bit earlier.